as per our standards and actually cybersecurity approaches, the principles we have to go behind in order to settle a policy to secure an environment. The authentication is a process via which uh, we stand in a second position versus a digital environment. Cybersecurity starts usually by authenticating every and each single component that tries to act, whether it is a subject or an object. Subject means a user. The user can be me, you, an individual, or it can be a process inside an environment. An object, a resource moving, a packet moving in a network or something like that. To authenticate, there have to be actually an identity presented. To authenticate, there have to be an identity presented. It means to authenticate me as a user versus the G Wave as an example. I have to present my username and my password. So presenting my username is my ID. And to present my password, I try to authenticate myself. If my password is correct, so I'm authenticated. To whom? To the system in question. If my password is wrong, so I'm not authenticated and the system failed my authentication or something like that. So this is one of the ways to make you understand what is authentication. We saw actually that there are more than one more than one authentication mechanism that we can go behind in order to authenticate individuals or objects or subjects or whatever the component in question. The password base is the weakest, the most let's say old authentication mechanism and the most persistent. I started with saying that it is the weakest in the sense of it is not the best option to go for whenever we try to build a secure system does not deliver resources unless authenticated to authenticated parties. But it is the most persistent, means it is the most used by developers and system security, let's say, specialists. We saw and we see again why it is. Others also will see, will define all of them, the security, the authentication mechanisms. And exactly this is the main purpose behind the objectives of this unit. Okay. As the first definition of what is authentication, I said it is a context of proven an identity of a subject versus a system or versus a framework or versus an environment. So an ID has to be presented, and then after a verification has to happen. The verification might return a validation or a refutal. Both of them, it is a verification. Those two tasks, whether a user has been granted access or not, whether the subject has been granted access or not, both, it is the authentication. So we may give an ID and a password, for example, or something like that, and the return is no, you are blocked. Is this an authentication process? The answer is yes, it's true. It is blocked, but it is authentication. Why? Because there have been a verification process. ID presented, verification happened. That's it. That's the authentication. Whether it is granted access or not, this is another scenario. This is another context. Grant an access is another process. But just the verifications stop there. That is the authentication mechanism. Any questions here, please?
No, doctor.
Okay, great. Okay, usually we refer to the standardized actually utilities. We refer to the standards that rule everything. We refer to the law, technical approach to talk about any uh, security feature. Then after we talk about the skills of a security specialist. Thus, the NIST is usually in action. The NIST, the National Institute of Standardization and Technology, is in action. It is the one actually that clearly authenticate the process of the authentication, digital authentication usually. And because of this only, we are defining the process of the authentication, that it is seen with the availability of three actors: the claimant, which is the one asking for being authenticated; the verifier, the engine in background responsible for granting or denying the access to verify the ID; and the party, actually the relaying party, it is the responsible for the making the engine run and delivering the services, authentication or whatever, the verification only. So three actors, they are in question, they are put in question here: the claimant, the verifier, the RP, relaying party. A model via which, or an architecture via which, we see an authentication process fully in action, because we cannot authenticate a party if it's not registered. So a claimant, here he is seen, it is not verified unless he is actually registered already. If he is not registered, he will never be recognized by the relying party. He will never be recognized by the relying party. So the authentication usually starts with the registration process. The authentication, usually to authenticate a subject, usually there have to be actually a registration process. So a claimant at the beginning, he has to register, and his credential has to be actually saved somewhere inside the system, inside the framework. And those saved credentials, they would be actually used by the verifier to allow the relying party to give him access, yes, to award him access. The subscriber is a claimant. He would register, his credentials would be saved somewhere inside the system, inside the framework, and those credentials, they would be actually usually used later on. It means after 1 week, after 1 month, after 1 year, after a period of time he tries to access the system, he will not register again. No. Immediately he will ask the relying party to give him access to the system by being authenticated. And the authentication will be actually done through the verifier, which he will read the credentials from the actually CSP actually here, where the credentials are saved. Any questions?
No, Mr. No, Mr.
Okay. A claimant, to be authenticated, usually he has to be, either he knows something to be authenticated, or he possesses something to be authenticated, or he is something to be authenticated, or he does something to be authenticated. Maybe all of them, maybe two of them, maybe three of them, maybe one of them, but at least one is required, minimum. Max, the four, maybe two, maybe three, maybe, it depends. But for an authentication, the minimum requirement is one of those means, those methodologies. Either the user, he knows something, I know something, I know a password, I know a pin, I can. He possesses something, he has actually a token or a smart card or something like that. He possesses something. Or he is something, he is I print or fingerprint, something like that. He is. Or he does something, he speaks, or he signs a signature, a hand signature, something like that. So he does something. So one of those mechanisms or one of those approaches can help a user to be authenticated versus a system. Authentication process is usually not deprived from the risks. Means it's not a scenario via which we may be elevating a process to a very high secure level. No, it is not. And the impact of the risk on an authentication is measured. It is a common understanding here, because an authentication, it has a breach impact that can be actually considered, but this consideration it's not technical. It's something to be measured based on the resources to reach. What does it mean? If we are authenticating a subject versus a system that delivers, for example, financial credits. Financial means money, means financial accounts or credentials, usernames and passwords, credit cards, numbers, or something like that. Very sensitive. Or an authentication is versus a social forum or social media, very very public platform. This is not sensitive at all. Everybody are seen and everything is exposed already on public. So the impact of a risk on top of an authentication is measured based on the service to deliver. It's not measured of the on a technical approach. Risk is a risk. Yet the risk on authentication on top of a system that gives access to a financial account is not the same on top of a system that gives access to a public forum. It's not the same because a financial system, a financial delivering system, it's a very sensitive case. It does not have to be public at all. Not even a single thought about that. So this is a very high, let's say, sensitive field, and the risk here is very high. So the risk here is very impactful. Yet the risk on a public forum, it's not riskful at all. Even if it's exposed, it's already public. So there is no fear about that. If there are risks, there is no problem. Thus, we talk about the measurement of the risk on an authentication problem, on an authentication breach, level 1, level 2, level 3, level 4. So it is based on a process that the authentication is given access to. It's not based on a technical approach. It's not. Is it clear? And those risks here, they have actually potential impacts. Whether it is little, some high, or very high, they have impacts. Those risks, they have impacts. Those impacts, they are still to be considered based on the understanding of the case, of the service case. It's not on a technical case. Low impact or very high impact means the disaster that a risk can cause. Is it a low disaster or a very high impact disaster? Hacking a forum, it's not like hacking a bank. Hacking a forum, it's a low impact. Hacking a bank, it's a very high impact. Is it clear? What I was explaining now, it is drawn to us in this matrix, let's say, and those are cases. Some of the cases that you can see actually, those are actually from our book only, but those are cases from real life that you may face. We may, all of them, all of us, we can face, and the levels of the risk that can be settled on top of any of those services can be drawn here. So uh, the risk for the level one, the risk for the level one on this, let's say, service is low. The risk on the level two for this service is moderate. Moderate. That's why, how we are drawing those things here. It is based on the understanding of the service only. You have to understand the service here. Later on in an exam or any actually interview or whatever, in any other similar case, you have to know what is this service in order to decide the risk impact on a level is low, high, or moderate. Low, high, or moderate. Low, high, or moderate, and so on.
دكتور على أي أساس وزعنا المستويات هذه low middle
This is what I was explaining now, and you ask in English. I said those are services. Those are services, 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 services. See, you can read. Those are services. Real case services that you can find online. You are using a website or a web application or a mobile application that delivers you some of those services. خدمات. Great. The levels actually that the risks can be subdivided into. They are four. The levels. Four levels: level one, level two, level three, level four. Starting from the very little means in the sense of it does not make any problem. If it's breached or if it's hacked, does not make any problem. There is no big consequences. Or it causes a very dramatic actually consequence, like for example when we hack a bank. It's a very problematic situation and it will cause a very impactful level. So here forum and here bank, what is that? What are those are services. So it's not technical when you say forum. It's not technical when you say bank. It's the service to deliver is sensitive. The service to deliver is sensitive. Okay, we have four levels. Either it's a low level, means it is not a dramatic, or it is a moderate, or it is a high level, or it is a very high level. The impact of the risk on top of each level, the impact of a risk on top of each level, the impact of risk on the low level, the impact of a risk on the moderate level, the impact of a risk on the high level, the impact of a risk on the very high level is either low, moderate, or high. There are three: low, moderate, or high. There are three impacts for each. For each. Okay, okay. The impact of the risk on the level one, it might be low, it might be moderate, it might be high. The impact of the risk on the level two, it might be low, it might be moderate, it might be high. The impact of the risk on the level three, it might be low, it might be moderate, it might be high. The impact of the risk on the level four, it might be low, it might be moderate, it might be high. So on each level, the impact can be seen any, the low, the moderate, the high. Who decides that? The service in question. The service in question. What is the service? And the service here decides, makes the cybersecurity specialist, you or me or any, decide the impact is low, moderate, or high. Taking an example. Taking an example here. Personal safety. For example, what is personal safety? For example, we are taking the example of the, for example, the surveillance camera that shoots videos and records videos for surveillance, means your photos and your images, your videos even, they are recorded in a database that the surveillance cameras use. Those are personal safety. Those are for the purpose of the personal safety. What is the risk level here? It's very dangerous here. It's not very low. It's not even moderate. It is high and it's very high. So we are not having any in the low, and we are not having any impact on the moderate. None, none. I am understanding this one. But if somebody of you says that it is moderate, it depends on you. So I will not say no, but we cannot see actually. If I tell you the example, your pictures and your videos would be exposed in a public network on Facebook or on Twitter. Is it okay? Absolutely no, it's not okay. It's a disaster. So it cannot be moderate. It is very dangerous. It is only 3 and 4. It is only 3 and 4. Thus, yes, on the level here 3, which is high, level 3, which is high, and level 4, which is very high. Yes, the personal safety is considered, and the risk is either high or very high. For the high, yes, little bit. Otherwise, for the very high, yes, it is very high. So we are saying it here for the high, maybe. For the high, maybe. Otherwise, it can only be very high. So you are stating here for the level 4, it is very high, high and moderate. For the level 3, which is high, mm, little bit. We can find some cases. We can find some cases where the personal safety actually details or data or profiles, yes, might be exposed at this level. We can accept. So thus we are seeing it low here. We are not seeing it none. We are seeing it low, not none. If it is none, means we cannot accept at all. We cannot accept. But here, in some cases, the recorded data can be shared amongst companies or amongst the security company or whatever. So it is high, but still can be shared. So we are saying low because there are cases where personal data or personal safety related data can be shared. It can be shared, but with precaution. Thus, we are saying low at this level. You have to read all the. There is one page. There is one page exactly describing all what I'm explaining about this actually matrix here in your book. Read it so many times. You will understand more. I believe that you understood me here, but even though you refer to the book and refer to this recording later on after the class, and you'll understand more. Refer to the recording, please. Let's pass. Okay, the password authenticated password-based authentication system. It's one of the very weak scenarios. It's not the best to choose. Yes, absolutely. But we are going to use credentials to authenticate the user, no more, no less. Actually, to grant him access. And based on those credentials, here we are going to grant group of services privileges to the authenticated candidate. Great. Issues behind the password based authentication mechanism is that there are technical approaches via which we can break the authentication process. We saw in the lab the brute force attack. It's one of the very famous scenarios via which we can break the authentication. We can access the system without permission. So this is one of the very famous issues a password-based authentication system is facing. The default accounts, they are still actually vulnerable. The default accounts, they are vulnerable to different attacks. Means whenever you buy a new network device, the new network settled device, it is equipped with default accounts. We find that in the digital security course. Those default accounts, they are vulnerable. Their credentials, they are famously known across the world, so they are vulnerable. Not only the password-based dictionary attack, or let's say the brute force attack, also the popular passwords can be utilized to attack systems. The very famous passwords, they are actually utilized everywhere. Admin123 is one very famous password, so we can use it to test, to make an attack, something like that. Guessing passwords, it's one of the techniques that it is causing an issue to a password-based authentication system. There are actually so many a long list of vulnerabilities behind of this authentication mechanism. So you have to explore them, all of them. We saw those actually technical problems in the digital security course. So you have to read. It's a matter of reading only. Uh, those security issues we faced here versus the password-based authentication mechanism can be actually countermeasured. Means there are security scenarios via which we can stop or at least limit those frauds or those vulnerabilities. We can limit them. Yes, absolutely. Okay. By controlling actually the behavior of the password-based authentication system, simply just to control the behavior, how he give access to the authentication interface, even the interface where you can type in your username and your password can be controlled. So this is one of the countermeasures. The input validation is another scenario via which we can control the password-based authentication system behavior. And at the end of the day, at the end, all the communicated data between the front end interface, where the credentials are inputted, and the back end and the verifier, actually it has to be encrypted, or it might be encrypted to elevate the security of this authentication mechanism. It is very weak, yes, as an authentication process, but it's the very commonly used. Still, it's very efficient. Why? Because in a budget wise, it is the most cheap authentication based mechanism, and it is the very fast to deploy, less in expenses and fast in deployment. So it is the very efficient so far. It is not the best, but the most efficient. You have to differentiate here. It's not the best because there are weaknesses, but it is the efficient. Why? Because in budget it is the cheapest, and in time it is the most fast. Any questions?
No, Mr.
Great. Uh, we go a little bit on and we talk about how to secure more the authentication system that uses the password based as an authentication mechanism. The first solution is to hash the passwords. What does it mean? It means you type your password in your text field, but the system will not see the password. We'll see the hash of your password. What does it mean? It means when the claimant gets registered, and his credentials would be saved inside the system, the credentials, they are not the username and password, they are not the ID and the password. No, they are the ID and the hash of the password. We define the hash in the cryptography unit. So the uh, the system will store the hash of the password and not the password itself. So the user will type a password and will type an ID and so on, and he will be registered. The system will not save the password, we save the hash of the password. More than that, more than that, this hash will later on be utilized to check to verify the validity of the user anytime he tries to log in. Yet the hash, it is not only to calculate the hash of the password, but to calculate the hash of the password plus a salt value, In the sense of, you type the password, for example, admin 123 Oman 2020. Okay, this is the password. This is what you typed as a password. The system will consider that plus he will add you a value, an extra value that he only recognizes. The system only recognizes, and he will save it for you, which is named salt. This is the salt. Okay, the system, he will save inside the system, inside his database, what? Your ID, your encrypted hashed password, here it is, which is the password plus the salt. Hashed will be saved here, plus what? Plus the added value, which is the salt value, separately saved in a column inside the database, inside an entity inside the database. Why? Because later on, when the user tries to log in, the system will recalculate the hash based on the ID typed. He will use the saved salt for the selected ID, and what the user typed as a password, he will calculate again. The hash, yes. And if he the system finds what he calculated again is similar to what it was saved already, he will let you in. Otherwise, he will block you. You have to understand it this way. You have to see it this way. What is a salt? It's a simple, actually, alphanumeric value that the system will generate. The system will generate and save it inside the let's say the data store. Not only database only, but it can be in a file-based mechanism. It is in the back end. At the end of the day, it's an alphanumerical value. It is to increase the difficulty to break the password-based authentication mechanism. It is to make it much more difficult to break, to block the hackers at the end of the day. And it is almost 99.99999% actually to be authentic to user actually knowledge. Means you not find a way how to guess it. It's not something that you can guess. It is something that the system imposes, and it will be actually for our human being brains. It is not something that you can guess. This way, you'll not be able to, or the systems or the hacker, they will not be able to crack your password in different systems. If they reach to break your password in one system, they will not be able to do it in another system. Why? Because the salt is not the same. The salt is not the same in different systems. The salt value. Great. Great. This actually, this feature, it is not based on standardized framework. It's not only Microsoft, but mainly it is a cross-platform approach, the context of the salt. Here we are defining the operating system, which is the Unix operating system, like the Ubuntu, like the Kali we installed in the lab. All of them, they are distributions from the Unix platform, Unix framework, and all of them, they enhance. They are actually the region from where the context of the salt, the added value to be utilized. We are deploying different standards that we define in the cryptography chapter. Still, this context is not the final security approach. Why? Because we are trying to increase the security of the password-based authentication system, but still the technology gets advanced. Remember that the processors that they were actually in action 10 years back, they are not the same processors they are active today. And still, amelioration and technology is bringing new features and new betterment to the technology. Supercomputers, they are actually getting involved in our daily life, not only to dedicate to the platforms. And those capabilities, they are actually being utilized by the attackers to break the password-based mechanism. Means calculations that would be actually much more faster, and they would be actually able to break what we were not able to break yesterday. I believe that you have to understand this saying here. Okay, to exactly, since the technology is being ameliorated, hashing a value, it's not one standardized based methodology to do. There are technologies, there are algorithms and different algorithms to do so. And those algorithms, they are using different key sizes to achieve a better hash results. The MD5, the message digest version 5, the message digest version 5 is one of the very famous hash generators. It uses actually, it is one of the very famous because it can generate up to 128-bit hash value, which is strong enough to say that it is secure, that you can trust. It's not unique, but we'll see the Bcrypt just in a while, which is one of the very famous also standards. It's much more complicated than the MD5, but it is built on top of this MD5 algorithm, like the DES and the triple DES, like the one we defined in the unit number 2, which is described in the digital encryption standard, or the triple digital encryption standard. It is a time consuming this decrypt, but it is much more complex than the MD5. See here, it can generate a 192-bit hash value as per the date of the book, no more, no less. Okay, we define the brute force and the dictionary attack in unit number 2, and still the same definition applies here. The same definition. We are not bringing something new. Just the application here is different. Here we are applying the dictionary attack and the brute force attack for the context of cracking a password-based authentication system, not to decrypt a cipher. In the unit number 2, we use the dictionary attack or the brute force to decrypt a cipher. Here we are using it to crack a password-based authentication system. Still, we use a list of passwords, and we have a field that sends a username. We have to capture it, and we are going to make a match. The system is going to make a match. So the dictionary attack or the brute force attack is seen in action. In this technology only, or in this feature only, if you remember well, in the lab we generated a long list made up, if you the number exactly was 1,477,000, something like that, passwords. It's a huge number in a few seconds only. Suppose that we are going to keep the system run for, let's say, 1 hour generating passwords. At that speed, we will generate a huge number of passwords that we will not be able as humans to finish counting in 1 hour only. Here we are talking about a rainbow table. This rainbow table, it holds a long, and it's really long, it's a huge number of passwords that the system will use. Rainbow table of attacks. This rainbow, it holds a multitude of passwords stored in a one file. It's a table that holds all of those passwords to be utilized later on for attacking a system. And because of this long multitude of passwords, it is almost any system would be actually cracked, because whatever the composition of your password, it would be an alphanumeric plus some symbols. The system will generate those passwords, and they would be actually found, and it would be actually guessed, and the system would be broken. It is a matter of time only. It is a matter of time only. So for the example here actually of a 1.4 gigabits rainbow table in a supercomputer, actually in a dedicated specificities, it is a matter of 13.8 seconds only to break that system. It's a very short time. It's a very short time. See the size of the file. They are passwords only. And see the time. It's a very short time to break the system. Thank you very much for today. See you next class, and remember, up to what we saw today is included in your